next important question. One kind of cake requires 200 gram of flour and 25 gram of fat, and another kind of cake requires 100 gram of flour and 50 gram of fat. Find the maximum number of cakes which can be made from 5 kilogram of flour and 1 kilogram of fat, assuming that there is no shortage of other ingredients used in making the cakes. Okay. So now let's solve it graphically. Now already I have just done a rough part here. What we are going to do it, first kind of cake and then second kind of cake. Now flour 200 grams and fat is 25 grams. In the second kind we are having 100 grams and 50 grams. Is it clear? Now how much flour is already available to us? They have given us 5 kilograms of flour. So converting in grams, this becomes 5000 grams, and the fat is 1 kilogram. So this becomes 1000 kilograms. Now number of cakes, these are X and Y, which we are going to make. Now this, if you can make this type of a rough sketch for the question, then this becomes a very interesting part, okay, and very easy also. Now let's start it. Let X cakes be made of first kind and Y cakes be made of another kind, means second kind. Okay, so we are writing second kind. Now objective function, maximum number, maximize Z is equal to X plus Y. How many cakes we can make? Okay. Now subject to constants, $200X plus 100Y is less than is equal to 5000 grams. Okay, so this can be flour constant in two types of cake. One thing. Second is 25X plus 50Y is less than is equal to 1000. IANTS. Fat constants in two types of cake, and we are having non-negative constants. Now this part, now we can write it. Or 2x plus y is less than is equal to 50. Number 1. or now this becomes x plus 2y is less than is equal to 40. Number 2, number 3. Bonding the lines to the corresponding inequations, we are having 2x plus y is equal to 50, fourth, and x plus 2y is equal to 40, fifth. Point of intersection, solving equation 4 and equation 5. Now already we have made a rough sketch, so they are intersecting at point B. So solving equation 4 and 5, we are getting point B as, when we are solving these two equations, we will be getting 20, 10. Okay, so this is point of intersection. Now first equation is, it is, for plotting it, we are having 2x plus y is equal to 50. 2x plus y is equal to 50. And second equation is x plus 2y is equal to 40. X plus 2y is equal to 40. Now, first equation, 2x plus y is equal to 50. Now, when we are taking y as 0, x becomes 25. When x is 0, y is 50. So we are having 25, this point, 25 comma 0, and this point 0 comma 50. Then we are having x plus 2y is equal to 40. When y is 0, x is 40, and when x is 0, y is 20. So we are having 40 comma 0 with point A, or we can write here A, 40 comma 0 and 0 comma 20. 0 comma 20 is already mentioned. Now point of intersection, that is B, it is 20 comma 10. Now checking for feasible reason. Now taking the arbitrary point, now first of all, for equation 1, put x is equal to 5, y is equal to 5. Let's check it. X is equal to 5 in equation 1. Here 2 times 5 is 10, plus 5 is 15, 15 is less than 50, therefore 5 comma 5 satisfies equation 2x plus y is less than is equal to 50, therefore shade towards 5 comma 5. For equation 2 is, now we are having this one, put 10 comma 10, 10 comma 10 satisfies equation x plus 2y is less than 40. Now 10 comma 10, 10 plus 10 times 2, 20, it becomes 30. So it satisfies the equation. Therefore, shade towards point 10 comma 10 for equation 2. And the most important is equation 3, x is greater than 0, y is greater than 0, shade in first quadrant. Is it clear? So we are having now now 5 comma 5 for equation number 1. Equation 1 is two x plus y is equal to 50. Equation 2 is x plus 2y is equal to 40. So for equation 1 now, first of all let us move for third part, x and y greater than equal to 0. Now y greater than equal to 0 this side and x greater than equal to this side. Okay, so it means we are shading in the first quadrant. So our shading will be this side, this side. Now 5 comma 5 for equation 1. 5 comma 5 approximately it falls this side. So for equation number 1, equation 1 is 2x plus y is 50. So our shading will be downwards like this. Equation 2, x plus 2y is less than is equal to 40. We have taken point 10 comma 10. Again 10 comma 10 is approximately here. So for this equation it will be this side. So what is the common reason? What is the feasible reason? Feasible reason is this part. X greater than 0, y greater than 0, then x plus 2y greater than 40, less than 40, and two x plus y like this. Okay, so we are having now A is not here. Let this point be A, B, and this point be C. Feasible reason is O, A, B, C and O. This point is C, okay, and it is 0 comma 20. Now we are having A, this part, B, C and O, origin. No. Corner points for the origin is 0 comma 0, for the A is 25 comma 0, for B 20 comma 10, that is this point, and for C 0 comma 20, total number of cakes z is equal to x plus y. Okay. So now A is 25, 0. So this becomes z is equal to 25 plus 0 is equal to 25. Then B 20, 10, z is equal to 20 plus 10 is equal to 30. C 0, 20, z is equal to 0 plus 20 is equal to 20. So maximum value is which one? Maximum number of cakes, maximum at B. Okay. So now maximum value of z is 30 at points A 20, 10. Now finally cakes of first kind and 10 cakes of second kind can be made. 20 cakes of first kind and 10 cakes of the second kind can be made, and total cakes made will be 30. This is the answer. Total cakes made will be the 30.